Hello and welcome everybody. In this brief tutorial, I'm going to introduce you to ClimateStudio and show you how to take a simple box energy model and find the EUI of that model. So this is the homepage for ClimateStudio. It's an energy modeling program that works through Rhino, and it will only work on a Windows PC interface. It will not work on an Apple machine on iOS, so keep that in mind. But it's a really great program that uses Energy Plus to do energy calculations, and it'll use radiance to run daylighting simulations. It's also a tool that can be used for climate data analysis and for shading studies, among other functions. It can be used for lead compliance with regard to daylighting. It's when I am working with teams on daylighting, I oftentimes see outputs that look like what you see on the web page here. But I'm going to run into Rhino, and I'm going to just create a very simple, again, shoebox energy model. I'm going to start off by taking just a very simple geometry. Let's just assume a single story building. I'm going to draw off here and say 90 feet by 90 feet by, let's say, 20 feet. Oh, and I don't have my units correct. So let's go over to here. Let's go to properties. If you're new to Rhino and you're working with this, you can go to properties and units, millimeters. That would be our problem. Let's go to feet, hit OK. Well, let's try that again. So we'll go here. Let's draw off a geometry. Again, I'm going to say 90 feet by 90 feet. And let's say 25-foot tall form. So there it is. I could go over here and render it, get a sense of what that looks like. And I'll go back to my wireframe. And if you have installed ClimateStudio, you're going to see the CS workflow button over here to the right, typically by default. And you're going to see a menu that looks like this. I'm going to click this first drop down, and you will see a menu of other functions that ClimateStudio can conduct. This is basically defining everything that the program can essentially do. And I'm going to pick for this tutorial, I'm going to go with thermal analysis, and notice that it offers the following here. In preparation for this video, I had already loaded climate data, but the way you can get to that, you see it loaded here. You can open up this folder, and it's going to give you access to the database. You can type in whether it's, so you're looking for New York or maybe Chicago, but I'm going to say in this case here, Indianapolis. Notice I have the international airport. I got a couple other options, Eagle Creek and whatnot. I'm going to pick international airport, hit OK. And that's going to now load that information. Let me pull this menu out just a little bit so you can see it better. Notice it's PMY-X data, so looking 2004 to 2018. Up to here, it's giving you some essential information that you may use in a climate data analysis. I am going to go here and notice that it's all in SI units. So if you want to switch that up, this button right here, that's blue SI, you can click that, and now it's in IP units. So you look here, suddenly you have degrees Fahrenheit, kilobtUs per square foot, and the wind speed in 9 miles per hour. So I am now confirmed to have my Indianapolis data in here. I'll go to this next item over here. I'm going to skip over this one. This is showing you, I'm not going to do much with this. I won't skip it. I'll just define it here a bit. It's showing different fuel sources and giving you some critical information on that. You can actually come in here and edit some of this information so you can have this highly tailored to the pounds of CO2, the price that you may have per kilowatt hour, whatever you want to adjust here, you can come in and adjust it for your project. This is going to help inform your analysis. Okay, so where I wanted to go next, this tab right here for your thermal zones. This becomes really important. This is where you're going to tell ClimateStudio what to do an analysis on, because you may have a model with several different geometric forms, and you just want to run an energy model for a specific form or just a specific part of your model. So I'm going to go over here to zone. I'm going to actually select my zone. Notice up here in the corner, you want to pick a closed geometry. I'm going to grab this entire thing. Notice that it's highlighted yellow and hit enter, and it's going to pull open this zone information. You can look through here. It's going to allow you to give that a name if you wish. Zone, since we just have one zone, I would just leave that by default. Notice here under building type, I can select any number of building types that are presented. I'm going to stick with office for this example. Down here, I can actually pick space use, and it's going to have some predefined inputs. Now I'm just going to go with one single thermal zone, but you could actually break out your model into smaller programmatic pieces, and you can get very specific with that. And notice there's a lot of ASHRAE 90.1 2019 defaults in here. I am just going to leave it at the office default up here. I see the occupancy information, equipment information, lighting. All this is giving you a little peek under the hood for what this model is assuming. Construction type. This is looking at a 90.1 2019 office climate zone 4 prescriptive default. And you can come to here and you can actually adjust these further if you wish. You can see there's some preloaded options in here that are tailored to climate zone 4. For intents and purposes here, I'm going to leave this at the default. You can see the um, facade, roof, infiltration information, all offered here. Foundation model, FC factor info. You can see glazing. I'm going to leave all that. If you wanted to change that, come over here and edit your space use type. You can go, so here, foundation, you can change that as you wish. Infiltration, you can come here and define that differently if you want to count infiltration or not. Here you can define, you see here some roof, facade, partitions, etc. You can get into this and click one of those, and it's going to give you all kinds of options. I am just for this quick tutorial going to leave it at the defaults. I'm not going to change any of this. I just wanted to show you briefly how you could go deeper and deeper into the model and change some of this information. But I'm going to leave it at the defaults here. Window to wall ratio. It's going to take that simple box geometry and it's going to add a certain proportionality of glazing to it. You can do this in a uniform sense for all sides of the model. You can also do it, break it down directionally and perhaps add a higher proportionality on certain parts of your mass. That's totally doable here in a very easy way. I'm going to leave it at uniform. I'm going to leave it at that 40% here. And then system type. Got the ideal air load defaults and coefficient of performance information. I'm going to leave that where it is. I'm going to hit OK and notice it adds that 40% of the wall surface being glazing now. So that's in here. There's a couple other buttons on this menu that we want to be aware of. So we have our zone now defined. Ground boundaries. You want your model to be grounded. If not, it's going to likely assume that your floor geometry is exposed to the outdoor environment. If I were to look at this right now, because I located my model at z equals 0, and I flip around here, you'll see that green diagrammatic color indicating the ground boundary has been defined. You can also define adiabatic boundaries. Let's say that let's say I'm modeling a floor and just one floor of a multi-floor building. Maybe this is the ground floor of a five-story building. And by that definition, I just want to look at the thermal zone of this first floor, and I don't want to assume the subsequent floors. Moreover, this would not be a roof plane in that case. It would actually be an adiabatic floor assembly. And by adiabatic, just meaning that it's thermally inconsequential. So I am going to make sure my snaps are on, and I'm going to actually create a plane. And let's see here, just define that. I'll say I'll snap it corner to corner. All right, let's pick that surface and move it to the top of the model there. Okay. So I will select that surface and I will come over here, my adiabatic boundary. I will select that. Notice that turns orange. That's indicating an adiabatic surface. And if I wanted to, so there's north, there's south, I could again add a plane. I could again snap a bit here. I'm just going to arbitrarily make that surface like you see there. Let me just select that. Let me move it again. We'll take it from that surface to there. Okay, so now what I'm gonna do is I'm gonna move it again, and let's just put it also at the top of the model. And now that I have that selected surface, I'm going to define that as a shading device by this button over here. And notice that it turned that light gray color. So I now have my thermal zone defined, adiabatic surface indicating that there are floors above this, and I have a shading device that is protecting that south glass. Okay, I think I'm ready to run this model. I'll go to this last tab over here, and notice it says ideal air load default. It's assuming this unicorn icon here that it's the ideal air load. It also can be a VAV system. It could be a dedicated outdoor air system with fan cool units, and it could be a DOAS system with VRF. I'm going to go ahead and assume the old bread and butter VAV system. Select that. I can change the inputs. I'm going to, for this initial shoebox model, I'm going to leave all this where it is. And notice it adds it here. Zone count one, that one thermal zone was what we assigned here. So right now, this shoebox model is assigned to the ideal air load default. I'm going to actually click this little zone plus button here, and I'm going to select that zone instead, hit OK. And now it's assigned to the VAV system. I will go up here and I will actually delete this one. So now we're just down to the single duct VAV system. I can edit the properties. So what I just had a second ago, I can come in here and change this as I see necessary. And once you have done this, we have now built our geometry. We have uh, defined the location in terms of climate data. We've gone through and added our utility information. Or at least checked it in this tutorial. We've defined our thermal zones, and we have assigned an HVAC schematic to the model. We're ready to go. So I can hit this play button, and it will immediately start running the Energy Plus model. This might take a few seconds, but for a single zone model of this size, it shouldn't take too long. Should work just fine for this brief tutorial. So it's running right now. This should just take a few more seconds and then it should populate the results. Running that information. It's running an Energy Plus model. So that does take a little bit of time. And there we go. Okay, so it now has results as noted here. You can expand this. Okay, so just expand this a little bit more so you can see it better. Okay, so what we have here are site EUI of 83. If you were to compare that to an Indianapolis-based office building looking at old 2003 CBEX data, you're likely to get an office building something near 100, maybe the upper 90s. So that passes the smell test. Got operational carbon information. Notice though, that's pounds of CO2 equivalent per square foot. Oftentimes you'll see that per square meter. So you want to make sure you've got your units correct. Energy cost, saved versus baseline EY, there's your 90, kind of acknowledging what I was just mentioning. And here we can look at energy use intensity. We can look at some other aspects of the energy assessment, but what you see here is going to show you the EUI on a per month basis, and you're going to see these color codes that are defining the different ways in which the model is anticipated to consume energy. And if I scroll down here further, you can see some additional information uh, on the thermal analysis. You can see air temperature, mean radiant temperature, operative temperature, relative humidity, and some other data down here. So that is a very brief tutorial to get you up and running, getting you into ClimateStudio, and helping you access the predicted energy use intensity of your early phase shoebox energy model. So I hope this was helpful and happy modeling.